everyone, I'm Isogai from Microsoft. As you might have guessed, I am Japanese, but this is a joint session with Dr. Nash, so I'd like to speak in Japanese in this session.
For joining us for this session to be presented by Quantinuum and Microsoft in terms of the recent accomplishment to advance the actual use case or usability of quantum computing for solving the real-world problem. I'm Naoyuki Isogai from Microsoft and
Nash Palaniswamy from Quantinuum. Thank you for coming and spending your time with us today, and I'm sure you're going to enjoy the presentation from Yuki-san.
So we're going to be presenting this session together. First, let me introduce the overview of the accomplishment to be done by, actually to have been done by Quantinuum and Microsoft together. Then, in the middle, I would like to hand over to Nash-san in terms of what kind of advanced technology of quantum computing of Quantinuum really enable that strong achievement together. Then I will take back for the conclusion and wrap up. Okay. So first, why Microsoft is driving quantum computing? For sure, Microsoft has been driving the innovation or striving for the innovation of computing itself for long, long years. So, advancing the computing itself, for sure, is one of the key motivation of Microsoft. That said, it's not only about that, right? Our motivation is really address the real world problem by whatever available and relevant computing technology, one of which definitely will turn out for quantum computing, because quantum computing going to provide the real precision and accuracy in terms of solving the problem related to quantum mechanics, right? That really is the motivation for us to drive quantum computing together with a wide variety of the ecosystem, especially Quantinuum. Then, what's going to be the requirement for us or for you to be able to tackle on those real-world problems taking advantage of quantum computer? One of the key aspects is scale. Because otherwise, right, if you try to tackle on those real-world problems with a very small number of qubits or computing resources, which can run on very short amount of time in accurate way, you won't be able to really address work on those very complex and long-ranging problems. That's the reason why we have been putting scale for quantum computer as a top aspiration or top north star to drive our innovation towards quantum computing. Then, are we already there to enable scaled range or scaled level of quantum computing? Not yet. In the level of scaled quantum computing, we definitely need to have thousands or millions of qubits run in a very precise way. We are not there yet. That said, we are driving the very solid and steady progress about that. If we take a look, or if we position that kind of really scaled quantum computing as a level 3 to really leverage for working on the real world problem, the state or situation where we have been would be level 1, which is all about NISQ, right? Then would it be really pragmatic and reliable if we just scale the NISQ? Apparently, the answer will be no, because just scaling the NISQ computers as it is or as they are will be, of course, increasing the computing capacity. At the same time, it will be just increasing the noise as well, right? So before scaling towards thousands or millions of qubits, there will need to be the level or phase to really enhance the reliability or resiliency of qubit so that noise will just be increased or scaled along with the computational resources scale at the end goal, right? Then what we want to share together with Quantinuum today is that we have accomplished the very reliable and resilient qubit by taking advantage of the strong combination of hardware provided by Quantinuum and software for virtualization to really incorporate the error diagnostic and correction within that logical qubit, which we call. So let's take a little bit further look into what we accomplished together. So first, we really enabled the most reliable and resilient logical qubit on the record in the world together. Back in April, we also published the journal to American Physical Society together to really prove that kind of attainment. Then how do we call it as really reliable or resilient logical qubit, right? With that logical qubit, we actually created 4 logical qubits on top of 30 physical qubits of Quantinuum to have enabled 800 times better or lower error rate by the combination of the strong hardware and our own software accomplishment, with enabling 14,000 times of computation without a single error. Of course, in the process of error, there have been, in the process of computation, there have been errors. That said, in the process of computation, those errors were diagnosed and corrected before the computation gets done. That enable that kind of very, very reliable and resilient outcome compared to the physical qubits computation. And another, notable accomplishment is the active syndrome extraction. It's very important to do that kind of syndrome extraction during the computation, not after the computation, so that the computation will not be stopped, even diagnosing and correcting those errors. The reason why this is very critical is going back to the scale thing, right? The reason why we need the scale quantum computing environment is because of the complexity nature or the long-running nature of the problem to be solved, right? Then, in the process of solving those complex and long-running problems, if the computation will need to be stopped to do the diagnostic, right? It will not be really pragmatic to use those kind of environment. So not only the error rate, but also this active syndrome extraction during the computation is also very important and crucial to get to the scalable state or level of quantum computing. So with that, I would like to hand over the mic, or actually quicker, to Nash-san.
You can hang it. I'll give it back to you.
Yeah.
Perfect. Well, thank you, Yuki-san. I think when I gave my presentation yesterday, I talked a little bit about H2 and my short timeline in quantum computing. So we're really proud of the H2 system, the system which was used for all these resilient level 2 computer. Microsoft has basically come out and said we're the only level 2 quantum computer on the planet. Just on the right side, this is something I never thought I'll ever see. I mentioned that Niels Bohr was my favorite scientist yesterday, and just seeing real atoms, right? Real ions going through was something amazing for me. I never thought I'd see that in my life. So this is really showing 32 ions going around in a racetrack. We can actually see those things in our video when you go to a machine. Tremendous achievement. This is our H2 system. I talked about a Helio system coming next year. That'll have a different type of trap, much better system. And a little bit about why this is the number one highest performance, highest fidelity machine on the planet. Is it's fully connected, 56 qubits, entangled at high fidelity. You can see the single qubit fidelity is 99.997. 2 qubit is at 99.87. Okay, and that's about 10 minus 2. And with what Microsoft did with the 800x improvement, it got it to 10 minus 5. Tremendous achievement, 99.8% spam. The crosstalk error is so low. Okay, that's because of the way that we have our traps and we have these zones. So we can actually do the entanglement without having crosstalk like the rest of the planet can. This architecture, we call it QCCD. And we have several features which actually allow these types of quantum error correction and detection, which is mid-circuit measurement. You can do that to get these active syndromes when you use these ancilla bits. These are some techniques which you can't do with other architectures. Okay? So this is some of the advantages which was used to get to a level 2 computer. So I'd like to thank Microsoft again, for the collaboration that we are working on all the time. We don't stop at this one result. We'll continue to work, as we improve this performance and get better and better fidelity and better performance and move to the next level of computation with quantum, get it to real commercial advantage. Okay.
Thank you, Nash-san.
Thank you.
So again, this is a recap of what's been enabled by the combination of unparalleled excellence of Quantinuum's H2 series and also Microsoft software technology, right? I really don't go by line here because it's pretty much covered in earlier slide. Then, in terms of the partnership between Quantinuum and Microsoft, this is something I also wanted to make sure of touching upon before wrapping up. Because, yes, as Nash-san mentioned, the high fidelity, unparalleled high fidelity of existing quantum computer hardware of Quantinuum was one of the key reasons to have engaged or partnered with Quantinuum on this achievement or this exercise from Microsoft side, right? That said, that only was not the reason. Quantinuum and Microsoft have been partnering since 2019. It's already 5 years strong partnership. Then not only providing Quantinuum quantum computer through Azure Quantum, not only that, right? We having also working on something together called QIR. QIR stands for Quantum Intermediate Representation. This is about somehow providing the common intermediate language for programming quantum computer, right? Why do we do so? Because this is all about enhancing the ecosystem. Not only providing the single programming language for quantum computers to do the coding to run programs. Then those programming will have nothing to do with any other architecture or any other programming languages for quantum computing. Again, that's not scalable to really tackle on the real world problem. Microsoft has been all about this concept for doing quantum computing. It definitely needs to be scalable and pragmatic, and also democratic, open for everyone to be able to take advantage of the power of quantum computing to solve the real world problem. Then Quantinuum definitely has been with us to enable that through this kind of consortium type of the approach, such as QIR. So we are so proud to have enabled this accomplishment on top of the long-range partnership between Quantinuum and Microsoft to make it accessible to whom really need that, right? Then, next question will be, how can people have access to those logical qubits on Azure with having Quantinuum underneath to enable that kind of reliable situation or level for quantum computing, right? Again, this goes back to our motivation to provide quantum computers or quantum computing environment. From Microsoft's perspective, again, providing quantum computing resources is not necessarily the goal, not necessarily the objective, rather a method, one of the methods to tackle on the real world problem, particularly around material science or chemistry type of the problem, which have by nature the very strong correlation or relevancy with quantum mechanics, right? Then Microsoft now has an offering or environment called Azure Quantum Elements. Azure Quantum Elements is not necessarily only providing quantum computers or quantum computing environment. Rather, it provides the heterogeneous computing resources across established HPC, high-performance computing environment, and also AI machine learning environment, and quantum computing when it's ready to really enable the optimal computing resources for relevant problem solving, right? We do have this Azure Quantum Elements private preview now. So anyone can apply for this Azure Quantum Element private preview on the website of Microsoft. Then, in near future, I would say in coming several months, we will be starting providing the logical qubit based on Quantinuum's physical qubits to the customers of Azure Quantum Elements private preview. So if any of you, or hopefully everyone here, are interested in logical qubits, please go ahead with signing up for Azure Quantum Elements private preview so that you will have the opportunity to join this in the near future to tackle on the real world problem by taking advantage of the scalable quantum computing environment for future. With that, we would like to wrap up this session. So are we going to open up for the Q&A?